Elite row.
You left a bunch of like punch cards.
Wait, you got so much money. What are you doing here?
All right, how's it going today?
This guy's like, I'm broke. Can't buy food.
So, bunch of topics to talk about today. So first thing, SLP proposals. So if you turned in your original SLP proposal on time, you got points for that, and also for the version 2 and the version 3. If you got a 0 on the SLP proposal original turn-in, you had until this morning to get your version 2 in, and I put comments a week ago asking usually to specify your milestones. That was the main problem that I was seeing. So if you did not turn in your version 2, turn in your SLP updates before, I think Wednesday is the deadline for version 3, okay, and you can still get 5 points on your proposal. But make sure you turn that in because it sets the tone for, certainly the rest of this course and theoretically the rest of the year, 3 quarters. On the subject of SLP proposals, there's still this opportunity to present to the engineering club Friday afternoons your ideas for your SLP. Okay, it's a 5 to 10 minute presentation, usually 5-minute talk, 5 minutes for questions. It gets you some extra credit in here, but also gets you practice talking about your idea, thinking about what you're working on, and getting some feedback from people. We also have some people coming from industry this Friday to the club to listen to presentations. I think there was 1 slot still available before I came to class at 10. So if you want a chance to actually talk to people who, work from this stuff from industry perspective, grab the last sign up for this week. But if that's taken, sign up for some Friday afternoon if you want to talk to the club about your proposal. Yeah.
What time again is ECS Club? 12.
Starts at 12. And it's a series of 10-minute slots, and I don't know what time the slots talk. It's sometime shortly after the meeting begins. And there's sign-up sheets on the wall of the collaboratorium. If you walk from here to the collaboratorium, the first window you encounter, it's on the other side of that window, just before the entrance. So take advantage of that. All right, homework 2. I downloaded homework 2 this morning. Over a quarter of the class did not have homework 2 available for me to download. So this is a problem because there's a good chance it means when it comes to PA3 it's not going to be available for download, and you don't want to get a 0 on PA3 because it's a big percentage of your grade. So if you've got a 0 showing for homework 2, try to figure out what the problem is. Talk to me if you aren't sure. And when you think the problem is resolved, send me an email and say, I think I have resolved the problem. Can you download HL2? And I will try it and I'll let you know yes or no. Because you want this to work so that when you submit PA3, you know that that's not going to hiccup. If I did succeed in downloading it, I still need to go through and make sure your script was called HL and you got the right stuff in there. But I'll do that in the next day and post a grade. All right, so questions on homework 2? Okay. So ODP 413, let's talk about that. So you were writing a function that counts the number of E's in a character array and returns that count as the value of the function. So here's my solution to it. Integer county car star arg, that's just the name of the function, the type of the argument it wants, and I'm calling that argument arg. You can call it whatever you want. And it's a loop, right? So C I'm using to count the number of times I see the letter E, and my loop goes from 0 to string length arg minus 1, and I check each element of arg bracket I, to see if it's equal to single quote E. Okay, single quote E says a character, And the elements of arg are characters, so I'm comparing a character to a character. Now, if I do something like this, right, try to compare it to a double quote E, I'm going to get a warning. That's a serious warning. Okay? C will run with some horrible warnings. It'll still let you run. It'll really only throw an error if it really can't figure out how it can possibly run. This will run, and the CPU will be perfectly happy to execute this, but it's telling you you're comparing an integer to a pointer. That's almost never something we want to do, right? Here we wanted to compare a character to a character, and we're comparing an integer to a pointer. Well, that's a very different thing. Arg bracket I is a character. Characters and integers are almost the same thing. But double quote E is an address in memory. It's not the character E. It's a memory location. It's a big, long hexadecimal number. And that's not what we're looking for. We're looking to see if this character is the character E, which is ASCII code 101. So that's a good error to pay attention to. And if you use single quotes, you don't get that warning.
What would it look like if you did run that?
It would just almost never find that it looked like a double quote E, and your count would almost always be a 0.
Okay.
So here's some sample code, right? Let's just look at what a single quote and a double quote E look like, and just print out their values with a %D. And it'll complain, right? Because it expects an int and it's getting a char star, but we can run it anyway. And so E in single quotes is the number 101. That's the ASCII code for an E. E in double quotes is 4,195,835.
If you
Why is
rerun
that
that, it
again?
would be different, right?
Actually, it's always the same, which is a little weird because it's in double quotes. Say again?
Why is that again? Why is it?
Because this number, 4,195,835, is a memory location. It's an address in memory. And what's happening is, in your C code, if you say something like double quote hello, the compiler looks around in memory, finds some spot, you know, wherever that is, and it stores an H there, an E, an L, an L, an O, and then a null terminator.
Oh, weird.
And then this thing is equal to the address of that first character. So if I try to print it out, it prints out this number. If I try to compare it to something, it compares this number.
But every time that you run it, it should be in a different spot in memory, right?
Yeah, except that since I put it inside double quotes, it goes into a different type of memory.
Whoa.
And in that type of memory, the value seems to be stable.
What about the single quote?
The single quote is, if I say single quote E, it just thinks 101.
Wait, so is there memory?
And somewhere there's a memory location and it stores a 101 there. But when I say single quote E, it's not the address of this, it's actually the value of it. Because this is a pointer,
Right.
right? And this is just a value.
So that's like, so is that, I'm sorry.
It's weird.
Okay.
It's,
Is it the ASCII code thing?
it's the ASCII code of a letter E,
Oh,
yes.
okay, so that's just the actual ASCII of
That's
E.
the actual ASCII
And
for a
then
letter
whereas
E.
hello was like a previous input saved somewhere.
Whereas hello is a array of characters saved somewhere.
Got it.
And the value of that string is actually the address where that first character is.
I don't know if I'm fully understanding. There's a spot in memory set aside just for quotation mark strings.
Well, just for things that are declared in a different way. So let's see if this will work. If not, then just forget I did this. So I'm going to make a character pointer called temp. I'm going to set it equal to quote hello. Going to print it out, and then I'm going to change the first character of that array to be an A and print it out again.
Should hello.
And it should say hello. Right? Instead it's segfaults.
Why?
And it's segfaults because when I set something up like this, it gets stored in a location of memory that's not writable by the program. And when I try to write it, it says, nope, you're not allowed to write that memory location, segfault. So that's the different area. It's not just for strings, but it's for things that can be read but not written.
So it doesn't even print the hello?
Yeah, it did.
It did? Okay.
Yeah. Right, temp
Oh,
equals
yeah.
hello, but then when I tried to modify, I got an error.
Weird.
Yeah.
So you can still read it though, right?
But I can still read it.
What would you do to get it to access that memory location?
Now we're getting deep.
Is that where you would use like fgets and like use a card star? Oh, Malik.
Yeah.
I don't like it.
No. So this is not on the exam, as they say.
Nice.
But we'll get to malloc another time.
Okay, are we going to use Malik and C in this
We're not going to
class?
really use malloc in 224.
Didn't we
We'll use
it
it heavily in 222.
Okay.
Didn't we, Wood?
Didn't we use it in Engine at all?
I think you touched on it in 121, yeah.
Okay.
But we should. I think we should not have to use malloc in 224.
Okay.
So forget everything you just saw.
Okay.
Gouge your eyes out. All of that. Okay. All right. So let's go back. All right. So yeah. So we want single quotes. That's the first thing. Second thing, we've got a for loop. We're going from 0 to string length of the argument. So if this is our string, this is element 0, 1, 2, 3, 4, 5, 6. We have no idea what's in element 6, right? Because the string is only 5 characters long. So it has 5 characters, and it has a null terminator. So the last character we want to look at is actually character 4. Okay, if I say what's the string length of hello, that should be a 5. Number of actual characters, not counting the null terminator. So I want to start from 0, and I want to go as long as my index is less than string length. So 0, 1, 2, 3, 4. When it's equal to string length, that's actually the null terminator, so I'm usually done at that point. So your classic for loop for this is for I equals 0, I less than string length, I plus plus. And then the if statement is just seeing if it's equal to the letter E and bumping up my count, and then returning that count value. Okay, so that's the function itself. How do you test it? So there's a count function. Here's a function I could use to test this. So when I say make a test bed to test your code, right, I'm just saying make a main program that calls your function in a number of interesting ways. So here's a main program. It's called main.c. It prototypes the count function, right? So this is just saying, what the function should look like. It expects a character pointer, it returns an integer. Here's my main program. I'm not worrying about argc, argv, or anything like that. Here I'm calling the count function. What am I passing to it? I'm passing the string hello. And the value of this count function is whatever this thing returns, the value of count. So I'm saying print count e returns %d, new line, quote, comma, whatever integer I have here, that's the value that should be printed. Well, the integer that's here is the integer that's returned by the count function. Right? I could say I equals count e, and then I could print out I, right? But here I'm just doing it in one, I'm combining those in one step. So I'm printing the value returned by count e. Well, this has 1e in it. This should return the value 1, so this should say count e returns 1. Here it should say 3, this should be 3, 0, 0, and so on. So that's a test bed. Okay, it's a set of code that exercises the function I'm developing, count e, and lets me see what that function's doing in different cases. So we can compile that. So I'll compile my output file. I'm going to call main. I'm just going to say compile main.c and count e.c. And then I'm just going to say main to execute it. And that shows me the results. And if I look at my main program, that should be the number of e's in each of these strings. And I did a few strings. I did a string that was all e's. I did a string containing no e's. I did a totally empty string. I did a string with 1 e in the beginning and a string with 1 e at the very end. These are all different test cases. So if I do something like this, for I equals 1, I less than length of temp, let's make it I less than or equal to length of temp, and so on, and I run that, I'm going to get some wrong numbers. My EEE should have said 3 and it only said 2. But hello was the right number, and my empty string was the right number. But if I hadn't done some of these test cases, I would think, hey, my code works perfectly. And I assess it and I get 0. Right? So part of this is trying to come up with clever test cases. And the more bugs you make, the better you are at debugging code. This is why I'm so good at like coming up with test cases, because I've made like every bug that you can imagine. If your counter is off by 1, right, having something in the beginning or at the end will be an edge case. If you have some embedded assumptions, like there's always characters in there, then testing with an empty string is going to be an edge case. It might throw a seg fault, right? So it's an exercise in sort of coming up with creative ways that you might break your code. And the more you do it, the easier that becomes. All right, does that make sense? All right, so let's look at 414. So 414, we're making a function called mix. And mix takes 3 character arrays as its arguments. It's declared to return an integer, but you don't do anything with the return value. So you can return any integer that you like. Okay, pick your favorite and return it. So what it does is it interleaves 2 strings, A and B. Take a character from A, character from B, character from A, character B, and just interleave them into the output string, which is the 3rd string. Bless you. And for convenience, you can assume that A and B have the same length as each other. So they're equal length strings, which makes things a little easier. And so the output string will be twice as big as the length of A and B. Okay, so when this function is called, it's given 3 strings, 3 character arrays. The initial value of the output array is meaningless. because it's going to get overwritten. Okay, but it's got to have some space because we're going to take A and B and mix them together and store that result into this output string. So let's make some test code for this. Okay, so I'm going to put in standard IO.h. And I'm going to prototype my function. And I'm not going to bother with argc, argv. I'm just going to make a void main function. So I'm just going to make a first string that's hello, a second string that's A, B, C, D, E, and I'm going to make a third string that's just a character array of 120 characters. And I'm going to say mix first, second, third. And I'm going to say after mix third equals, and I'll print out the value of third as a %s. I'm going to put it in angle brackets because I really want to know if there's extra spaces added at the end or anything weird like that.
I think your equal sign is.
That's a dash instead. Thank you. All right, so you mix first, second, store it in third, and I'll print out the value of third. It's test code, right? It's just a way, I've already got a mix function that I've written, so I just want to see if it does something reasonable. So let's try this. So I'll compile testit.c and mix.c into an output file called testit. Oh, I didn't expect that. I knew this looked funny. Alright, so I got to declare first and second to be character pointers, not characters. Right? So those were really good warnings to pay attention to also. Didn't get any errors, so that code would still run. Well, let's see what it does. And you know, it might actually work, which is unfortunate. Okay, good. Segfault. But you know, sometimes it'll work even despite warnings, but try to get rid of your warnings, because there's usually a good reason for them. Okay, so let's run test it. And it tells me after my mix, third equals, and that looks like hello and A, B, C, D, E mixed together the way they should be. So that seems reasonable. Here's something you don't want to do. This should segfault. It may actually work. But yes, third is a character array. It's a pointer to a character, but I haven't allocated space for it. And remember, mix is just going to take those first two strings, combine them, and store them into this output array. Well, if I don't know where third is pointing to, how do I know that I'm allowed to put characters into that spot? So this says third is a character array, but it hasn't given it a value. And it's probably equal to 0. And when I run this, mix is going to try to save this new string it's creating, starting at location 0. And when you do that, you get a segfault, because you can't write memory location 0.
So, strange question.
Mm-hmm.
Why doesn't the program just create an array that fits whatever needs to be fit in it?
You mean the mix function?
The cars why doesn't it just,
Because it doesn't know how big it needs to be. It could allocate some space initially, but how much would it allocate?
oh, okay.
Right? Because when the program starts, all it knows is it's a car pointer. And it's really inside the mix function where it's storing things into this array
Yeah.
that we might start to understand it needs to be this big or that big. But, so some languages do that though, right? Some languages will make this thing grow automatically to always be big enough. Like Bash, for example. If you have a string and you try to add something else to the end of it, it just grows bigger. But that's possible because Bash is interpreted, right? There's a program running that's interpreting your Bash commands. This is actually trying to convert it into machine code. And at the level of machine code where it's just the CPU, PIC processor, for example, it can't move things around and make sure there's enough space.
Okay,
So it forces us.
so in the case of Bash, it's because there's another program in the background that's actually doing that work effect?
Yeah.
Okay.
And if it needs the string to be longer and there's no space, well, it'll do some stuff to make more space and use that for where the variable's stored. Cool question.
I have a question about the prototype. So if the prototype mixes initialize as an integer, how come you don't have to return an integer from that function?
So you do have to return an integer, but I don't have to use it when I call it. So I could say I equals mix, but and that would be more proper.
Nice.
Right, to do something like that. That would be the proper way to call it. But C is actually forgiving. It won't even give you a warning if you don't use that return value. So, and I should have made this function void, but I didn't, and it's already posted, so it's an int. But that's pretty common. Same with fgets. Sometimes we call fgets and we don't use its return value, even though it's returning something. Same with scanf, although we should use that value. All right. Other questions on this? So I could also test this by saying, right, I could just put in some strings like that. And then all I've got to do is declare my output string.
Does it make hey hey?
I don't know what it'll make.
Hey,
Yeah,
hey.
something. There's almost the association of higher education in there. But like this, you can sort of go to town and start making some test cases. So you can try mixing in some spaces. You can try mix two empty strings together. You can mix two spaces with an interesting string, and so on and so forth, right? And again, you want to try to exercise your code. Anything that you're not sure about, try to make a test case for it. And you know, one of the nice things about a test bed like this is if you run this and your code seg faults, right? You go ahead and you tweak your code and you just relink it with this and try it again. Your test cases are preserved in your code. And again, when you find a thing that like crashes your program or gives you a bad result, that's really, really valuable. And you want to hold on to that. You want to go back and see exactly what you did to generate that error. And so if you've got a program that's generating test cases, right, that can be useful. Right, but spend some time thinking about it. Right, this is not precious code in itself. It's a sample of it. But come up with your own test cases. Experiment. Depending on how you write your code, there may be something like, I'm not sure if this is the right way I'm handling this. Right, put in some test code for it. And getting to where you can develop tests like this is another part of just sort of getting to be a better programmer. There's people whose whole job is just coming up with test cases, trying to break code. I'm really good at breaking code because I've made all these mistakes before.
Breaking things in general.
Yeah, but the more mistakes you make, the more you think of things, right? The more times you've written a for loop and started from 1 instead of 0, or been off by 1, or done 1 too many things, or 1 too few things, right? The more times you've done that, the more likely you're going to think of, okay, let's make a test case to see if that's going on here, right? And I've made all these mistakes, hundreds of times, so I come up with lots of ways to break things.
Great. So I did the homework last night,
Okay,
and I forgot to make you a reporter.
okay.
Does that prevent me from getting points on it?
Yeah. Yeah, so the deadline's firm, but it's just a homework grade, so it's the same as the ODPs. But the important part is make sure that you fix whatever the problem was, and then send me an email and say, I think I fixed the problem, can you check if homework 2 is set up correctly? And I'll try to download it again and let you know yes or no, and then you're set for PA3.
We get an email if there were any problems with ours?
No, you got a 0.
Okay. Oh, so it is graded?
If it wasn't there, I put in a 0 to let people know.
Okay.
Was it dash or fine?
A dash, you're fine for now. Yeah, I still got to make sure it's actually got the file in it, but if I was able to pull it down at all, then it's probably fine. And I'll look at those later today or tomorrow. All right, so how do we make this ODP 414? How do we make this mix function? So we're reading in A and B, and we're going to produce out. And we want to interleave A and B. So how do we write code for this? One thing I like to do when I'm trying to write code, especially code I haven't written before, is try to do whatever the problem is myself manually. Right? So my goal here, I'm on a desert island and a pigeon came up to me and said, here's 2 strings, can you interleave them and make an output string? And so I grab my charcoal and my piece of wood, and what do? Well, I write down H, A, E, B, L, C, L, D, O, E, and I throw a null terminator on the end. And then I go on to another hallucination. All right, so there's my output string. Okay, how did I do that? So the trick here is when you're doing something to also be trying to observe what's going on and see if you can break it down into a set of steps. And this is hard, especially with things that are easy for us to do, like let's just interleave these and write an output string. It's such a basic thing. How do you actually figure out what the steps are? So you've got to learn to introspect, to somehow, while you're doing this, make note of what's going on. One way to do this is to try to describe to somebody else how to do this. Right? They don't know that they're supposed to interleave these. You're supposed to tell them a series of steps to produce this string from these 2 strings. So how did I do this? Well, I started off with an empty string for my output, so that's important. And I looked at the first string and I looked at the first letter. And I copied that to the first letter of my output string. And then I looked at the first letter of my second string and I copied that to the second spot on my output string. And then I somehow moved to the second letter of A, and I knew to copy that to the third spot of the output string. So we need some more variables here, right? We need something that's telling us where should we be writing to in this output string. And that's what we call an index. It can be just an integer, but it's telling us the position where we want to write the next letter in the output. So I might call this output I. And we also need to know which character we're reading from in these strings, so I might call this AI, and I might call this BI. And we've got an algorithm going now, right? So all of these things started at 0. And when I say, okay, let's take this first letter from here and copy that to the first position in my output, we're doing something like out bracket out I equals A bracket AI. And then I'm going to copy this first letter to the second position in my output, so I need to increment my output index. And now I'm going to say out I equals B bracket BI. So that copies my A into here. And I'm going to need to output index to increment, so now I'm pointing to this third spot. Well, now I want to copy the second letter from A instead of the first letter, so I want AI to increment, so I also want to do a ++ AI. And I can go back up to the top and do this again. But I also need to increment BI before I do that. And now if I think about this 6-step algorithm, this will start copying from A and B alternately and storing in the output array. Yeah?
Couldn't you just use one variable for I instead of AI and BI?
Yeah, so if you think about this, you'll find out that AI and BI are always the same value. Because we're doing first letter, second letter, third letter, third letter. So we don't really need a separate AI and BI. We could have just one variable. If you like 2 variables, use 2 variables though. Right, if that makes it clearer to you, go for it. If you really want to go crazy, you don't really need a separate variable for your output, because if you know you're reading the 3rd character here, you're writing either the 5th or 6th character in your output, so you could write some math to figure out that. But do what makes sense to you. And how often do we loop? Well, we could loop until we get to the null terminator, or we could make a for loop, and we could look at the string length of either of these. They're the same length, and we could say for AI equals 0 to 4, right? And then we wouldn't need to increment AI. And when we're done with all of this, our output string is going to look like this, but it's not going to have the null terminator on it. And you got to have a null terminator on the output because it's supposed to be a C string. So you got to figure out where that null terminator belongs, and there's at least 4 or 5 different ways I can think of to do that.
Like if null terminator A, then got it.
Yeah. So if you do this, right, out I will probably be pointing at where the null terminator should go. But you could also do some math. If you got 5 letters, you know the output's going to be 10 characters long. And those will be from 0 to 9, so you could just store it at character 2 times the length of either of these strings. So that would work. But don't try to take the string length of out and use that to figure out where the null terminator is, because string length doesn't work until you have a null terminator. Right? So you got to kind of barehand it to put the null in, and then you can use string length and stuff. So again, it's just an example, right? This is not the code you're going to write, but think about how you would do this by hand, how you would do this interleave, and then start trying to write down what some of the steps are that you're doing. All right, I had someone teaching yoga do this one day. They wanted us to like explain to our partner what to do to go through a sun salutation. So you were saying, you know, lift your arms, do this kind of stuff. And about 10 seconds in, she's like, don't forget to tell them to breathe. It's like, oh yeah, take a breath. It's like, so figuring these out isn't a challenge sometimes, right? But the better you are at doing this, the more successful you're going to be with programming in general. Because usually we can figure out how to do something, and we're just trying to get the computer to do it because it's faster and it doesn't get bored, right? But we're asking it to do something we already know how to do, so we want to be able to figure out how we do things. All right. I also want to mention something that I mentioned mentioned in the earlier class. When we write something like integer mix, car star, with a semicolon at the end, this is a function prototype. When we call this function, we say something like, maybe integer I equals mix, A comma B comma out. That's a function call.
So we have to assign it to something to call
You
it?
don't have to.
How else can you call it?
You can just say mix. Kind of like printf.
Okay.
The difference is you don't include the variable.
Yeah, we don't have something on the left of it.
No, I mean like when you call the function versus when you're actually.
Yeah. So so let me put up a third one, and then we'll compare them. So this is the function. I'm just going to say the function code. It's actually the definition, but I don't want to confuse terms. 3 different times that we're going to have something that looks kind of like the other thing, right? This is the actual function code. Okay, let's look at this one first. I've got the name of the function, I've got the type of return value, I've got the types of arguments, and I also have variables next to each of those types. Why? Because I want to do something in here with each of those arguments. So if I want to access an element from that first argument, it's got to have a name for that variable, right? I can't just say this is a car star. I got to give it a name so I can use that car star in my function's code. So we'll have return type, function name, variable types followed by names of variables, right? Close parenthesis, no semicolon, but a curly bracket. Body of the function, a return somewhere which should return an integer, and then a closing curly bracket. So that's how we write a function. When we call the function, we have the function name parentheses, and we just list variable names. We don't say car star A, right? We don't have to, because the system already knows this is going to be a car star. We just put in the name of the variable we want to pass. And it doesn't have to be A, it could be whatever, right?
Even though you declared it as A?
Yeah, I mean, I could have said,
They just have to match, right?
Yeah.
Okay.
It just has to be a car star of some type. Okay, so that's calling a function, and you can use the return value, variable equals that, or you can just, if it's an int, you don't have to use it. But usually we assign it to something. Okay, the function prototype is kind of a mix of these two. It's the type of the return value, it's the name of the function, it's the type of variables we're going to pass, but no variable names. Okay, so this is just the variable names, this is just the type of the variable, this is both. And then the function prototype has a semicolon at the end to say I'm not going to write the actual body of the function here. Yeah.
Do you need the prototype to call it if it's already in the like somewhere on the?
Yeah, you need to prototype it regardless.
Okay.
Unless it's a local function.
If it's a local function, you're
That's the
okay.
other day.
So yeah, prototype it, and then call it wherever you want, define it wherever you want, and you can define it before or after you call it. Right? Main can be the first function in your file. That's perfectly fine as long as somewhere there's a definition for these things.
But that's
right?
only if
But
it's
put
prototyped at the top.
But put the prototypes in the top. Yeah.
Sorry, Nick.
Okay, good. All right. Really quick. I've had people ask me about how to practice on this stuff. So one of the sites I found that I think is pretty good, I've got some people playing around with it. If you want some practice, play around with this, let me know if it's useful. W3 Resource seems to be free, and if you come down to exercises with Online Editor, click on C Programming, and there's just tons of practice problems here. So declarations and basic expressions, 85 exercises. So write a C program to print your name, date of birth, and mobile phone number. And you can click go to the editor and you can type your code in here. right? And you can run your code, and it'll show your output down here. And it says, oh, I needed a semicolon. Okay, add a semicolon and run your code. And it runs and it prints out, haha. And if you're not sure how to do this,
Query your code.
you can click on Solutions. And it'll show you the output it should produce. It'll show you the C code. It'll give you a flow chart. And then it'll give you a window where you can copy and paste and change and make some tries. And it starts off with, sort of these basic declarations and such. Basic algorithms start getting into some more things like find the difference between some number and 51, right? Or take two integers and return return true if one of them is 30, otherwise, or if their sum is 30.
Does it have an API?
I don't think so. It might. I haven't looked around.
Because if it does, you could make a Discord bot where you could just use a command, paste in some code, and it'll return whatever.
That would be
you
cool.
want.
That'd be a good SLP.
Would it?
If you go to the input-output section, these tend to use fgets and scanf. And so these are good practice for the stuff that we've been hitting the past week or this week, fgets and scanf. So those are the input-output ones. So take a look at it if you want, right? See if it's useful, but it's a chance to write a bunch of code and just work on these sort of smaller problems, get instant feedback, and if you're stuck, you can see the solutions. And there's 10 of these, but there's like 80 or 70 of some of the other ones. So take a look at that. All right, I posted a study guide for the midterm. Take a look at that, bring questions tomorrow, and we'll talk about it then.
Do you have the